TypeScript. I'm Mike North, and I'm a senior staff engineer at LinkedIn, where I work on developer infrastructure. I've been a front-end master's teacher since 2015. Today, I'm here to talk to you about full-stack TypeScript. You may enjoy using TypeScript for your browser-based or your server-side code, which is no surprise because it offers a great authoring experience and you catch entire categories of bugs at build time before they ever affect a single user. One of the downsides to working this way, it's not really a downside, but something we don't have yet in a setup like this, is the ability to get the benefits of type checking across an API call. This is to say, anytime you fetch data and you get a response back, you find yourself having to assert that, yeah, I expect this payload to be of a particular type, and there's nothing that makes sure that all of that stays in alignment except your own vigilance as a human being. In the project we're going to work on today, we're going to try to create a system that looks more like this, where you can kind of see how the green color represents one set of types that are shared across the client and server, and then another set of types that represent how data is actually persisted in our database. That's sort of this purple color here. What this means is you get all the benefits you already love about TypeScript, like the ability to confidently refactor, make sure you haven't left any dangling things. You get that across these network calls, right? And to do that, we're going to use GraphQL. So the scenario we're going to explore today involves using TypeScript for all of our client and server-side code, GraphQL for our API query language and our wire format, meaning the way we construct our JSON as it travels over the network. And we're going to focus on using a very simple relational database that's just based off of a JSON file. It's important to understand that if you were to swap that out for something more realistic, like a SQL relational database or a document store like MongoDB, everything we're working on today will still benefit you greatly. You can even replace your backend with something that's not written in TypeScript, and you'll get some of the same benefits that we're going to enjoy. The way we're going to get hands-on with all of these great tools is by building a Twitter clone. At the beginning of the day, we're going to start out with our UI completely based off of hard-coded static data. It'll look great, but it won't do much. By the end of the day, you'll be creating new tweets, and you'll be able to like and unlike tweets, not to mention the fact that everything you see on the screen will be powered by real data coming from your database through GraphQL into the UI, a much more realistic scenario. Before we get into the project, let's talk a little bit about what GraphQL is and what problems it aims to solve. So let's imagine a hypothetical scenario where we are building a new page for an existing app. Let's imagine we have this screen on the right already, and we're being asked to build something like what you see on the left. So we may have an API endpoint that already exists that produces a lot of detailed information to power this right side of the screen. But we may need some different things on the left, maybe a field that doesn't exist yet. For example, what if we wanted to enable or disable this little book button based on the doctor's current schedule? So we have a couple choices in terms of how we want to proceed if we want to go and do this with a RESTful API. First, we could use the existing endpoint as is and add this availability field. And if we imagine that that might involve talking to some calendar system, which could take a little while, this means everything that's asking for information about a doctor gets a little bit slower. We could build an entirely new endpoint that produces data only for this availability field, and we could ask for the existing doctor information and this new thing in parallel. This is going to result in a lot of little fragmented supplemental API resources, and it's going to be very difficult to keep everything well organized over a long period of time. The third option is we could build an entirely new API endpoint that gives us everything we need for this new scenario we need to handle. This is going to result in a lot of duplicate code where you'll have, doctor detail view, doctor summary view, doctor advanced view, doctor admin view, and all of a sudden this whole idea of leveraging a single API endpoint for doctor is gone, right? That's not ideal either. Finally, we could modify the existing endpoint so that it produces a different response depending on a query param that we pass in. The fourth option we have is to modify the existing API endpoint. For example, providing a query param that tells the API whether to produce a summary or a details view, which may involve different fields for each. This is going to become difficult to manage at scale, especially if we don't establish a strong convention across all of the resources we have to manage. What does summary mean? What does details mean? In addition, if we have multiple different options that all can influence each other as new scenarios need to be handled, you can see how we end up having to worry about a lot of different combinations of things and how they interact with each other. Even if we had these three different, flags that we could turn on that would influence the way a doctor, is represented, we'll end up with n factorial scenarios, even if we just worry about pairs of options and how they interact with each other. It starts to get very complicated. So GraphQL aims to solve problems like this one, in that a client asks for the data that it needs, and we can avoid problems like overfetching by producing only the data that's asked for and no more. We'll learn more about the details of GraphQL by getting hands-on and tackling the concepts that are involved one by one. For now, let's dig into the workshop project and examine the starting point code. First, you should clone the GitHub repo, which is Mike North full stack TS. After you have your local working copy, I recommend you install Volta, which ensures that you're going to use the same Node and Yarn versions that I do when I'm running the project for the class. To install the dependencies for the project, just run yarn. Once you have it locally cloned, you can run yarn build to create your first build, and then run yarn dev to start up the server. I'm going to go ahead and do that for us right now. Yarn to install the dependencies. Looks like a build is happening automatically, which is great. This shouldn't do much. Oops, well, if I can spell build correctly. Great, and now I should be able to run yarn dev, and I should see a nice little banner saying the server is running on localhost 1234. There it is. May happen twice for the first time you start it up, but that's no big deal. So you can click this first link here, localhost 1234, and you should see something that looks like this, the Twitter UI. So where will we find ourselves at the end of this course? We're going to start with this Twitter app that's purely hard-coded on the client side. It's just pulling fixture data from arrays that are in those client-side modules. By the end of the day, we'll be able to create new tweaks, and we'll be able to interact with that like button. We should be able to see the little heart light up and go away, and the count should increment. And all of the data we see on the UI should be coming, ultimately, from our database and traveling to the UI through GraphQL. In terms of what we won't end up touching in this course, this is stuff that is sort of beyond the scope of what we're focusing on. We shouldn't have to touch any CSS. We shouldn't have to install any new dependencies. We shouldn't have to change the TypeScript config. And we should not have to worry too much about how our backend interacts with the database. Right? We're just going to use that DB class, and that has methods on it ready to go. It has everything that you should need on it. And we'll consider that to be a separate topic, like the ORM aspect of things. The first thing we're going to need to do is set up an Apollo server. And we're going to do that by creating a new module, Apollo Server TS, in the source folder of the server subproject. I'm going to go ahead and do that now. And then the contents of the file should be everything below. And we're going to paste this in and then walk through this file and describe exactly what it is we're dealing with here. So I'm going to go in here, Apollo server.ts, and paste. Okay, so a lot going on here. And I'm just going to create a little breathing room. So we're building a function, it looks like it takes in a database of some sort, an HTTP server and an Express application. So this database is necessary because we want to attach this database eventually to something called a context. And this is just a little object that's, for convenience, available to anywhere that we're fetching data, right? It's almost like making this globally available to our data fetching code. And this will be much more clear later. We're not using it for now. That's why we're prepending it with an underscore. A little pro tip here. TypeScript, if you have like the no unused parameters compiler option enabled, it will light up things like this, right? This thing is declared, but its value is never read. Prepending it with an underscore tells TypeScript to kind of, don't worry about it, right? So this comes from other languages where this is a language feature, and it's easy to spot these as unused. So that's why we're using an underscore here, and when we use it, we'll delete that underscore. All right, now we have this typedefs thing. So let's get into that last, but I'll tell you that this is the GraphQL schema, and we're going to talk about what that means independently. So I'll collapse that for a moment, but just for now, say that it describes the types. This will become our source of truth for the types that are going over the wire, over our network. That's what this will evolve into. So that's this typedefs variable, and then we're creating an Apollo server, passing in our typedefs, and we're installing a plugin that effectively lets us wire this thing up with Express as a middleware. So that's why we're using this Apollo Server Express package here. We're starting up GraphQL, like starting up the Apollo server, and then calling this apply middleware function, which kind of installs it onto the main Express app. And remember, that's what that is passed into here. So ultimately, what we're doing is we're creating an Express app somewhere else, wherever we're using this function, and we're passing it in to create Apollo server. And then this function we're looking at here, it'll instantiate an Apollo server, it'll install the Apollo server onto the Express app, and then it'll return the Apollo server, because we might need that somewhere else. Now, let's talk about this thing here, the GraphQL schema. And it's in this tagged template literal with GQL. And that's important here because there are a bunch of nice little VS Code extensions that light this up, syntax highlight it, give you little autocompletes if you use this GQL name here. It also happens to do some other stuff that processes the string. So what are we dealing with here? Well, first off, this is equivalent to a set of interfaces in the TypeScript world. And you can see down here, we have a type called user, and we have a type called suggestion. These are the things that we'll start with. Now, also there's this type called query. Query is special in the GraphQL world. This is kind of the entry point when we're asking for data. So in the REST world, you can think of this as your GET requests. So here, we have something where it's like a user, someone's asking for the current user. And down here, we have something that says, I want an array of suggestions. In the Twitter UI, by the way, this is the suggestions area, this little who to follow thing. And we see just one item in there. Great, and so we can see like current user, this returns a user, suggestions, and then we see these square brackets here, seems array-ish. This is actually the way to denote an array of suggestions. Just wrap it in square brackets. There's no concept of a tuple in GraphQL, so that's why, like, you might look at this if you're using your TypeScript intuition here, this looks like a tuple of length 1 with 1 suggestion in it. No, this is the way GraphQL represents arrays. And then we have these exclamation points here. So in TypeScript, we use question marks to indicate optional properties. By default, things are optional in the GraphQL world. And by that, I mean they're nullable fields. They could come back null, like there is no current user. Maybe that means that we're not logged in. It could be. An exclamation mark is the way we say something is non-nullable. So it's sort of an inversion of the way you think about this. You don't have to say when something is optional. You have to say when something is required, when the types should represent that this is always here. I got a user back. I will have an ID. I will have a name, right? We'll end up with some nullable things that are missing this exclamation mark later on. And often these are things that we want, that they're the expensive things to assemble. In our example of that doctor UI, remember we might have to hit someone's calendar to see if they're busy or not. That would be a good example of something that you would make nullable, because if nobody asks for it, you want to be able to just say, like, don't worry about it. We're not going to get that. We'll get your information back to you fast rather than comprehensive. All right, now finally, like I have two exclamation marks here. I have suggestion, bang, and then that's inside this little array notation. And then I have another bang outside of it. What does this mean? So first off, we can look at this, and this means the user object will always be there. It will not be a null. And this is the equivalent exclamation mark there, right? I'm going to give you an array back. It's never going to be missing. What this inner one means is that you will find no nulls within the array. So it's about whether members of the collection can be null versus the collection itself being null. And you have two independent non-nullable operators there to indicate those two different things.
But it could still be empty, right?
The question is, could it still be empty? Absolutely. You can still have an empty array that contains no nulls. That meets both requirements. No nulls in the array, and the array is present. That means that in our backend code, even if somebody did not ask for suggestions, well, no, it doesn't make that sense in this case because it's a top-level query. But let's say, what if we had this done here? Another one, right? Like a user has suggestions. You know, it's a has-many relationship here. In this case, anytime we marshal the data together, we gather together data to say, I've fetched a user back. And even if what was requested was like these three fields here and nothing else, we would be obligated to make this an empty array. You know, like something has to be there in our backend code if we say it is non-nullable. So that's something that you have to think about carefully. And we'll get to that when we start dealing with relationships. You know, it's sort of a tight coupling between, can we save time by avoiding putting this data together? And is it possible for this field to be missing, like null, on the record? They're sort of interrelated in this situation.
And what enforces that requirement then, I guess?
That's a very good question. What enforces that requirement? In our example today, two things. At compile time, you will have type information that is built from this schema, and you will have TypeScript doing the enforcing. At runtime, the GraphQL infrastructure that's part of Apollo server, that will actually validate that your schema matches the code that is aligned with your schema, and that you're returning the right thing. And we're going to hit some of those errors, but there is some help because there's such a strong opinion about how data is shaped and how we ask for data. There is a validation thing that helps us ensure we have everything wired up correctly. We will hit that problem and then solve it. It is planned. My usual style of failure-driven development. OK, so that's basically all we have here. We talked about arrays. We talked about this exclamation mark. One thing I didn't talk about yet was sort of the primitive types. So you have strings, you have numbers, you have strings, you have booleans, you have numbers. Actually, you have an int type here. We could do this, and it would be totally fine. Yep. So I should not leave it like that, though. That's asking for problems. These are your primitive entities. You are missing a couple things, like you don't have a date, but you should think of these as mapping one-to-one with what you could put in JSON. Now, you can define your own entities, right? these are called scalars, by the way. You can define your own scalars if you like. We're not going to get into that. I would leave that to a course dedicated to GraphQL. We're more focused on compatibility between GraphQL and TypeScript and how you can get the benefits of everything working together. But that hopefully describes everything you're seeing here. There are no interfaces. Everything sort of begins with type so far. So we've created this one file. Let's continue on with our instructions. So hopefully we understand everything that's going on in this code we just copied and pasted. OK, so in the entry point for the server code, which is index.ts, we're going to add some imports. So let's go ahead and do that. Imports go at the top. And we're going to add the following two lines immediately below the static route, right? This is where the images are served up, the fav icon, all of just the static files. So we're going to put this below where we see the static stuff. And that is here. And we're using the imports now, which is great. And then there's one last thing we're going to do just to make our life easier. And it's a small little change in a logging line here that will give us a nice clickable link to a convenient thing. This will take us to the Apollo dev tools. So instead of this empty string, we're going to replace it with Apollo server GraphQL path. Paste. OK. And I believe that should be enough to get us up and running. We go all the way down. I don't see any errors. I already see this string here, slash, GraphQL. That wasn't there before. So I'm going to click on this second link, localhost 3000 / GraphQL. And you should see something like this. So this is the Apollo Studio entry point. And I can hit query my server. You can see we're still running on localhost here. And now we'll be off localhost, but we're going to still be hitting our own API. So you should see yourself looking at something like this. You won't see this query here. This is sort of left over from when I was testing things out. But this is where you can, this is where you document your API, where you can explore it. We're going to be using this extensively today. And I'm going to just try something. Let's see what happens. I'm going to, in this, on the side thing here, the side rail, I'm going to say, I want to make a query. I want to query for current user. And it's giving me fields to pick from. Let me just ask for the current user's name. And let's fire this off. And we get an error message. So this is an answer to the question, who's doing the validating for me? We can see this is at runtime. We're getting some good feedback here. Cannot return null for a non-nullable field, query.currentUser. Another way to say this is we've not implemented anything that will return a current user. All we've done is set up the GraphQL server with nothing wired up to it yet. So it's going to return null for everything, no matter what we ask for. But this is an example of it's kind of type checking happening at runtime. So we just did our test query. We saw that that failed. Let's proceed to the next step. What we're going to need in order to actually give GraphQL, give Apollo, some data to emit, well, we'll have to create something called a resolver. And the job of the resolver is effectively to gather things together. Maybe it reads the equivalent of path params or query params, right? It reads things that are part of the request coming in, and then it produces pieces of the data that are organized into the response. If you've ever used something like Redux, you can think of these kind of like, reducers, where you have these little subparts that handle a little piece of state, but then the way everything is organized together, it's sort of done at a higher level. So in a reducer, maybe you're just adding a new number to an array, and that's one little thing. But in the bigger picture, this array is deeply nested into this one little spot. So we don't have to worry about creating this payload that eventually, the consumer of the API gets. We can just worry about dealing with this one little field. So let's create our first resolve. To create our first resolver, we're going to need to go back into our Apollo server TS file. And because we're going to end up using this database now, we can remove that underscore that was telling TypeScript to not worry about the fact that we were leaving that variable unused. So let's go ahead and do that first. So here we go. We'll go up to the top. We'll delete that underscore. Now TypeScript's going to nag us. We'll take care of that in a moment. Next, we're going to insert this code somewhere before we create our instance of Apollo server. Why? Because we're going to pass this in to the Apollo server constructor. And this is our first resolver. And you can see here we have this as a top-level property of this object, query with a capital Q. And you may recall that in our schema, right, that GQL string with backticks, we also had a top-level thing called query. It was a type query. We can go here and look at it right here. So the resolver kind of should match one-to-one, at least with this query type. So we've got current user and we've got suggestions. And current user returns a user. Suggestions returns an array of things, right? That's what we see right up here. So we're creating the equivalent to that, something that matches up nicely with our schema. So let's grab this, and let's insert it right above our Apollo server instantiation. And then we're going to add this to the arguments passed into Apollo server. It's into this single configuration object. We're also going to add this function here called context. So I told you that this context object, this is, by the way, it's kind of an express concept, but it carries through to Apollo Studio or Apollo server as well. It's just this object that's always available in any of our resolvers, right? Any of these little functions, context is one of the arguments that you get. So in this case, if we have our database, this gives us a nice little convenient handle to grab our database, and it's right where we need it. Later, we're going to use this for any cached records that we need to put someplace, where we have things that might cascade through multiple resolvers, where maybe we get a tweet, and then we have to, in a separate function, get the author for a tweet. Anything that we want to save, like some work that can be reused, we might also store that on this context object. Now, this can be either an object or a function that returns an object. There is a significant difference between those. If it's just an object, that object remains the same for the life of your application. And what that means for you is if you're using this as like a temporary scratch pad of sorts, things will be left there between requests, right? So let's imagine that you use it to hold temporarily like some calculated result, maybe a count of how many times a thing has happened. A subsequent request, you might find that oh, you're not starting with like a 0, you're starting with 10 because we've already counted up to 10. So if you have a function that returns this object, you get a new one each and every time. That's an important difference here. And in this case, we kind of want this to be on a per request basis, a clean slate. Like if we were to store, for example, information about a user here with their auth token, you would want some guarantee that this will get thrown away, it won't leak between requests. All right, so let's paste this in. Resolvers and context. Resolvers and context. Save. And let's go back to our GraphQL DevTools. And let's see what happens. I'm going to just run the same query again. Let me make this a little bit bigger so we can see it really well. I'm going to run the same query again. And look at that. No more error. We're getting that fixture data, right, coming through. I can also, another advantage to GraphQL, I can combine the retrieval of two different kinds of things into a single request. I could get this list of suggestions as well. Now, in this case, it's going to be an empty array, but this is another advantage over like a REST API design. You don't need to make n requests for n resources. This, in fact, was a key reason that GraphQL, or key problem that GraphQL solved for Facebook, where this was around the time where they were like rethinking their mobile strategy. And for their native iOS and Android apps, they were like, the number of requests they were having to make to assemble everything on the Facebook page, like messages and feed items and photos and all this stuff. It was just, there was so much going on. And the more they broke things up into microservices, the more they found that they were making, dozens and dozens of requests just for that first page load. So this lets you kind of combine everything into one big pile. You get everything that was asked for, you return it all at once, and this reduces bottlenecks like the number of concurrent connections that can be made, or situations where multiple round trips are required in order to assemble something. Makes it real nice and easy. So great, we have a GraphQL API now. That was hopefully not too painful. So the next thing we're going to do is we want to break that resolver and that typedefs variable that holds our GraphQL schema. We want to get those out of this Apollo server file. I want this Apollo server.ts file to be boring, the kind of thing we hardly ever have to touch. That's really about wiring up the Express middleware. There's a schema that we'll end up, altering significantly over time. It'll be a pretty big file by the end of the day. We want that in its own place, and then this resolver thing is going to get very, very big if we keep it as a single file. Similar to, like in the Redux world, if you have all of your reducers and all of your actions in one place, that becomes like a 2,000 line monstrosity very quickly. So that's where we're headed next. Getting the schema out, getting the resolvers out, and breaking our resolver down into sub-objects. So the first thing we need to do in order to get our schema and resolver out, well, we're going to deal with the schema first, but we need to take the stuff that's in that GQL tagged template string, right? And we're going to move it into a .graphql file at the root of our project. Why? Well, if we're going to make this the single source of truth for any types that are going over the network, it doesn't really just belong to server. It belongs to the project as a whole. And there's a lot of tooling that works really well on these .schema files, and not everything can sort of strip these special strings out of a TypeScript code base. So this enables a wider variety of tooling. So let's go ahead and make that move. You can follow the instructions here, or you can kind of follow me as I do this. But we're going to go to our Apollo server TS. We're going to grab everything that's in this string here, the whole thing, cut it. I can get rid of this. And then in the root of the project, I'm going to create a schema.graphql, and gives you, if you have VS Code icons, you'll see it light up as a special file type. That's how you know you did it right. And I'm just going to paste that there and give it a quick little format. And there we go. So that's what we got. That's part one. And we've broken our Apollo server now, right? Like we had this typedefs thing. I can see the file, the tab is red and it's unhappy. This thing's not here anymore. So the next thing we'll need to do is import that file into this TypeScript module so that we kind of get back to our working state. And to do that, we're going to have to use some packages called GraphQL tools that will allow us to perform this import. So we're going to add these imports to that Apollo server TS module. And these three have to do with the importing. And then this last one, this is just a constant with the path to that schema.graphql file we just created. That's defined within the project. So let's add these imports up top. You can also clean up this unused import here. We're not going to end up using this. I mean, if you care to do so. Great. And now, in our top level module scope, we're going to create this load schema thing, right? So this is going to load the schema and transform it into the right data structure. And it uses a GraphQL file loader. So there are different ways you could store this information. There are JSON formats for GraphQL schemas, but we have a .schema file. That's what this GraphQL file loader is designed to parse. So let's put this in top level module scope right below the imports. And you can see we used a lot of those imports just now. And finally, we're going to use this and this. We're going to kind of smush it all together. So instead of passing type defs to Apollo server, we're going to kind of assemble our resolvers and our schema together and use that to create our Apollo server. Going to delete all the plus signs, delete type defs. Make sure you bring resolvers into this object. This is a little, I copy-pasted the diff incorrectly as I was cleaning it up. So add resolvers to schema. You should have both resolvers and schema passed into it. And if we hit save, and if we go back to our API tools here, I'm going to reload it just to make sure everything's fresh. And we run that same query again, everything should work. So now we're at a state where we have this nice schema held up at the top of our project, and we're importing it in, and things are working exactly as they were before. Next, we're going to do something similar with our resolvers. So we're both going to get it out of the Apollo server TS file, and we're going to break it up into sub-objects. For now, there's only going to be one sub-object. But in the end, we want kind of a central place where, well, let's say, in the end, we want each top-level collection of resolvers. And when we talk about a resolver, that's one of these functions here. We want each family of them to be in its own TypeScript module. And then we want one file where everything's sort of brought together in alignment with the way the schema is defined. And that's going to be just sort of the final wire up step where there's not much interesting going on there. It's almost like importing stuff, assembling it into the object, and re-exporting it. So let's go ahead and get started with that. In the source folder of the server subproject, let's create a new module called resolvers.ts. And we're going to begin by going into Apollo server, grabbing this whole resolvers thing, getting it out of there, pasting it into this resolvers TS, and then make it the default export. And then in Apollo server, that's okay, we'll do it the hard way. Import resolvers from resolvers. And now, again, I love coming back up for air very shortly after each of these steps. That way we make sure we don't break things and then write a whole lot of code on top of it. Go back to our dev tools here, make that API call, and it works. It still works. So we've done this quick little refactor. Now I want to break this out into its own thing. So we can close Apollo server TS. This file just got boring. Like, there's not much that's going to evolve here. The exception being we might mess with this a little bit as we need to put more things onto that context object, like little caches for certain records. But the rest of it we're not going to touch for the rest of the day, the rest of the class. So let's make ourselves a folder to contain all of our resolvers. And we'll make one called a module within that folder called query. And I kind of like to name these with capital letters so that they kind of match with this convention that you see in both the GraphQL schema and the way the resolvers are organized. So I'll grab this whole thing, and I'm going to make this I'm going to make it a variable and then make it the default export. And then here, we'll use our nice little enhanced object literal magic. And we can kind of just like have an import. If we make it this nice capital Q query, we can very easily just sort of wire it up, because that is both the key and the value. You know, we only have to make it this one little word. It'll end up looking very nice and neat. If you like. You could give it a different name if you want. And one more time, let's make sure everything's working. Great. So nice to have that thing running and to not have to stop and restart our server, right? So great. What have we just completed? Well, our schema is in a separate file, and our resolvers are now organized very nicely. And this is going to get quite big. Like our resolver area, that's where the bulk of our interesting stuff in this app is going to happen, at least on the server side. The next thing we're going to do is add types to our resolver. So we've been operating without a net, so to speak, up to this point. By that I mean in my resolvers, like I could put a bunch of junk in here that will not make Apollo happy. There's nothing here that enforces that I do the right thing or I return the right thing, and this will cause all sorts of annoying things to happen. And in order for us to have this, in order to deliver on the promise I've made that we can have types defined in one place and nice type checking and enforcement of those types all the way from, you know, our resolvers over the wire into our UI, like we're going to have to address this. And that's what we're about to do next. And this is potentially one of the more exciting things that we're going to do in this project. And that is generating TypeScript code based on that GraphQL schema. Now, everything's set up for you right now such that you can just run yarn code gen. And we're going to do that, and then we're going to look at what I had in place in order to make this work. So do this from within the server sub-project. Run yarn code gen. So I'm going to open a new terminal here. Yarn code gen. Sorry, I'm going to make a quick git commit first. All right, yarn code gen. And hopefully you'll see no errors. You'll see 2 green check marks here. You can see that like some files changed, so my server bounced and came back up. And let's make sure that everything's still working. We go back to our Apollo Studio. We click run. Looks like it's still good. All right, so what just happened? Well, you may notice that there is a new file. A new file appears, right? Resolvers types.generated.ts. So you can name these files whatever you want, this file. You can name it whatever you want. I like having .generated.ts or some convention like that. It makes it very easy for me to know I shouldn't touch this file myself ever. These are files that you should be able to blow away and recreate based on your GraphQL schema as your schema evolves. So if we look at the contents of this file, you can see, hey, here are our scalars. We've got ID, we've got string, we've got Boolean. These are sort of the most primitive types in the GraphQL world, and we can see a mapping of these capital lettered things into their TypeScript equivalents. Here is something that looks like our query interface. And we've got our current user and our suggestions. Let's look at our query resolver here. There's current user and suggestions. So it looks like these are kind of return types of our resolvers. This is what our client can expect to get if asking for these kinds of things. And then we've got our suggestion and our user type. Great. So this represents the TypeScript equivalent of these GraphQL entities. And they're all exported from this module, which means we're free to import them and use them in our code, right? These are sort of your models, so to speak. Down here, we have more types. And some of these we're not going to get into, like there's GraphQL has this concept of subscriptions where you could say, tell me when something changes. A very advanced concept and tricky to implement in a performant way. But we've also got some resolver types like this, resolver type wrapper. We probably have a query resolvers. And look at that. Query resolvers, it's got a current user, it's got suggestion. So these are the things we're going to use to type our resolvers. So with that, let's get going. Oh, by the way, if you see type errors immediately following running yarn code gen, just bounce your TypeScript server. If you're using VS Code, there's a command restart TypeScript server. It's just a lot's kind of changing behind the scenes outside the context of the editor. So VS Code doesn't see that you're editing a file or saving it, just something changes behind the scenes. Sometimes if you see red squiggles and you think they shouldn't be there, always good to restart it. So at the highest level, we're going to type the big mega resolver object that's returned, or that's the default export from resolvers.ts. So we'll import this resolvers type from this generated file, and we will type the return type of our create resolvers function. Actually, I don't think we have a function here, but we can update it to make it like that if we want. Effectively, we just need the export to be typed this way. So whether you have a function that exports it or we just have a variable that's a default export, I think that's where we ended up. So let's go to resolvers. Let's add this. And then let's make this of the right type. Great. So now we would appropriately be yelled at if we added junk here, which is great. Now, one problem is that this query thing, if we look at what's imported, it's just sort of inferring the type from whatever's exported, which is great for this file. But over here, you know, it kind of is what it is. So part of the problem here is if I do this, everything kind of looks okay here. If I like mess with this, make the method name wrong, I'm not getting the type errors that I would hope to get. Let me restart my TypeScript server just to be safe. Yeah, I'm getting no type errors. So we really want to type this as well, right? So the way we're going to do that, let me undo my deliberate messing things up here. We're going to import query resolvers. Here we go. And make sure you make it a local path. Sorry, it's .. And now, hopefully, yep. So if I don't have the right names here that are coming from my GraphQL schema, I will get the red squiggles that tell me I've been bad. So that's it. So in resolvers.ts, we use this sort of top level type. And then for each sort of object that contains a set of resolvers, we can have like query resolvers or user resolvers or suggestion resolvers. And we'll talk more about when we have to build our first one, we'll talk about why we would have that and what purpose it serves. So great. There's some sample data we can return just to take advantage of our types. Instead of that empty suggestions array, we can paste the sample data in and return this instead. And what we should see, just note that there's only one suggestion here. When we complete a change in our UI and we actually consume this data, we should see 2 of these things show up. So let's return this from suggestions. All right, we're going to just test this with our server here, our dev tool. Okay, awesome. Note that there's a lot more on suggestions I could get. I could get the avatar URL if I want. And you see how I'm kind of getting what I ask for. I can ask for only the name or only the ID. All right, now let's deal with context. So this is where we have this nice little convenience object that's going to be available within each of these resolvers. So it's actually the third argument. It's this right here. And currently, it's an any. But what we want is to be able to do something like this, like grab the DB off of this thing. And then we could say db.get stuff. And it'll just be there, handed to us just where we need it for convenience. So we want typing to help us understand what's possible there. And that's what we're about to do. So in our resolvers.ts, we're going to define an interface for this context object. And for now, it's just going to have this DB on it. So we're going to have to import this so we get its type and create an object with a DB property. Pretty simple. So we're adding this to the top of resolvers.ts. And we want to export this because we'll need it in other places. Next, we're going to pass this type in as a type param to both of the resolver types we just applied. Both the one at the top level, the resolvers thing, and the query resolvers. They both take this as a type param. So we can add it here. And then in query.ts, up at the top, we can add it here. And we'll have to import it. // or //. And what does this mean? Well, now this little DB thing we put in here, look at that. Now we can do DB dot, and we get create favorite, create tweet, create user. We get all this good stuff. This is how we're going to go and retrieve our data. It's really nice and convenient to have that there and have that typed for us. We're not going to use this quite yet. So we'll use our little underscore trick. We'll kind of leave it there for later. This is unused, but that's OK. Great. One last place that we need to apply this type, and that is where this context object is created. Remember that little function in Apollo server? This thing here, right? We're going to make this return a Twitter resolver context. That means if we put extra junk on here, it will be appropriately scolded for that. So what is the end result that we get here? Well, if in resolvers we say I need a thing that's an any array, I should be told hey, you got to give me that array. You have to initialize this with an empty array or something, when things start up. And it also means that in my query resolvers, down here, I could do thing, and I would get this. So here's all of the array prototype things. So let's say I do this, right? And then go back here. We say, no, I don't want that anymore. Things should light up appropriately. Like this is saying, hey, this thing's gone. So we have typing on this context object now. We also make sure that we're returning the right things now that we've added types to the resolvers themselves. So if we forget to return here, it's going to say, hey, look, I expected you to give me an array of suggestions here. Like this should be returning an array of suggestions or promise that resolves to an array of suggestions. Does anyone want to guess why there's this promise that resolves to an array? What would that let us do? The fact that we can return an array or a promise that resolves to that array.
Get data in the middle?
Yeah, we could get data in the middle. We can make it an async function, right? You can just put the word async before the function, and now we can await within the function, and things will just work as expected. So if you return a promise from one of these, Apollo will just wait for it, as needed, which is really nice. No special ceremony required. So great. I think we're at a point now where we have typing that works. One last check, make sure things are still operating. Seems good. Seems great. The next change we're going to make is wiring up our UI so that it consumes real data. And this is where we're going to get into the React app, right? This is where we're going to start making those queries and getting data flowing into that React app. So the first thing we need to do is we'll be opening our client subproject. Is we will need to import Apollo client. So we've got the Apollo client itself, and this is just, you can think of this as the vanilla JavaScript thing that makes the GraphQL queries. We've got Apollo provider, which is a component that uses the React context API to make it possible throughout the app to fire off queries. And then we have this thing called in-memory cache, and this theoretically helps us store data and access it, maybe from multiple components where we need the exact same query. We don't have to worry too much about n of the exact same request going out within a very short period of time. So those are the imports we need. We're going to create our Apollo client, passing a cache into it. So you can do this right below the imports. And then we're going to create our Apollo provider, which is going to wrap the app component. So we're doing this in index.tsx. You could do this in your app.tsx as well. You want this to, cover everything else that's within your app, or at least wherever you're fetching data. So we can go down here to where our app component is, right down here. And I'm going to put it within this error boundary component. Can someone tell me what an error boundary is in React, if you've used this before? It's like a catch. Think of it that way. So if there's a problem that occurs rendering something, this will intercept it, and its job is to put something on the screen so that we don't have to watch our console quite so much. We can just watch the rendered DOM. All right, so there's our Apollo provider. Copilot helping me out like a pro. And now what this means is I can use Apollo's hook API to make queries. And that's both the equivalent of a GET request and a POST request. So we would say queries are for fetching data, and then there's something we'll talk about later called a mutation, and that's changing or destroying data. So that's all we should have to do in this file. To recap, we imported the Apollo stuff. We instantiated a client with an in-memory cache. Here's our URL. It's the same one, by the way, that we're hitting for our dev tools. And then down here, we're wrapping our app in the Apollo provider. That's it. So now it's time for us to create our first operation. And this word operation is often used to describe, queries that are defined in your code base, where you're either fetching data or you're mutating data, but these are things that your API consumer is performing. So we're going to, there's some data in app.tsx, in fact, quite a lot of data. So you can see we have our current user, we have an array of trends, we have an array of suggestions. So these two things are both in the right sidebar over here. Here's our trends up here. These are our suggestions. Our current user is driving this header area over here, as well as the sidebar, right? That's like the user's name and their handle. So all of that is sort of loaded with the app. It's like the initial load at the topmost level, because there's no routing here, so to speak. We want to replace these arrays with real queries. And we're going to first start by asking for the current user and the suggestions. So before we can make a query, we need to import this GQL utility, which is the same thing that we used for our type definitions in our first setup for Apollo server. It's that tagged template literal where we can define, that special string that defines, a query in this case. It was the schema before, but we could use it for a query now. And then this is part of code that will be generated for us. And this is about, it's a type that defines what we need to pass in and what we can expect back from a particular query. So we can expect this here to error until we generate some code. It's normal for it to error. But let's add these to the top of app.tsx. And let me make sure. Yep, I was just double checking. I don't have a folder here called generated yet. I want it to fail as it will fail for you. All right, next, it's time for us to make our query. So I like to make these, all caps snake case constants. And we're going to wrap it in this GQL tag template literal. And you can see here it kind of looks a little bit like interfaces, sort of almost like JSON without the punctuation. You can think of these as, it's the same stuff that we're passing in here in our tool, right? So this is, a top-level query, and then the fields we want to retrieve. And another top-level query, and the fields we want to retrieve. What you name it here is not going to be of great consequence the way we're using things today, but there are things you can do to refer to this later on. So let's grab this, add it to our app.tsx. I'm going to put it right down here below all of the fixture data. So now that this has been added, we can run our CodeGen utility. It's the same command, just run it in the client folder. So it's yarn CodeGen. And you should see, some check marks, everything's successful. And you should see that a new folder has appeared called generated, GraphQL.tsx. This is a good time for me to talk about how is all of this happening? So there's a library called, I think it's GraphQL CodeGen. There it is. So this is the project that's doing this generating. And there are config files like this that effectively define where GraphQL stuff can be found, and it's capable of parsing these strings from TypeScript. And then what do you want generated? So this is what's giving, where I'm defining the name of the file. And then these are plugins. So this is going to define like what is the output, what exactly is operating on the parsed GraphQL stuff. And then that's the exact same way it's working on the server, except you can see I have resolvers, right? Like I have operations generated on the client side. I have resolvers generated on the server side. Imagine if you had a mid-tier API that had both operations that it was sending to some other backend and resolvers it was using to serve data to someone else that's upstream or downstream. You might have both operations and resolvers in here. So that's it. And this, I just want to show you the list of languages that are supported. A lot of TypeScript, React, you can have it wired up for Vue or Angular. C#, Java, you can use it to generate flow types. So this is a great compatibility layer if you're migrating from Flow to TypeScript or back. So this is it is quite flexible. So now that that's generated on our front end, this import that we had up here, it is no longer causing a problem. In fact, it's got a really complicated type coming back. That's a complicated type we didn't have to write, but let's look at exactly what's happening here. So it looks like this is a function. So it's not strictly a type. This is actually a function that's returning something. And it's saying Apollo use query, and it's passing in a query of some kind. And it's got get current user query variables. So here's the query. Here are the variables passed to this query. These might be thought of as like the query params or the path params that you would put in a URL for a REST API call of some sort. And then we have a return type, which is, sorry, it's actually going to be inferred based on what Apollo use query returns. So this is the code gen, looking at the schema, understanding what does this query need, what do we expect to get back. Let's put it into action. So inside the component, we're going to invoke this hook, get use current user query. And you may wonder, like if you've used React hooks before, use state, use effect, things like that, often you'll pass something into this, but this is something that's already pre-baked for us. It's part of the generated code. It has that query baked in. It has the right type associated with it. It's all ready to go. What we get back are three things. We get loading, error, and data. So these let us conditionally render something if this request is in progress, if something went wrong, and then if this is a nullable type, there's always a possibility that no data will be returned. So for now, we're just going to emit cursory things. We're going to return cursory things from the component if we run into those situations, and that will let us get to this point where we'll use destructured assignment to pick out data, like the current user and the array of suggestions. We'll grab that from the response payload. So I'm going to grab this and paste it into my component before the return. So that'll go down here, right here. And now we have to use this data somewhere. But if we look at this, we can see, hey, look at those nice little types coming through. Like nowhere have I said that there's this avatar URL or anything like that. But it's all coming through. This is all based on our GraphQL schema. So I'm going to start to pass this data into our components. So here's the first one. Just replacing this red line with the green line below it. And that is right here. Now, the reason I'm doing this is we haven't handled everything that's on our fixture data for the current user. In particular, there's this favorites thing. And we don't have that yet. So I'm going to need to do basically an object assign, kind of merge these things together. I'm going to keep fixture data in there, but I'll override it with real data. For now, we'll get a mix. So we can save that. And then the other place we can use this is suggestions. And this we should be able to replace outright. So right bar. Actually, here, suggestions. There we go. And I think this means, can we delete suggestions? We can. It's not used anymore. Fixture data gone. Now, we'll know this works. If you recall, we had one suggestion of who to follow before. We should see more than one. And we do. Here's jQuery's Twitter account showing up. So now, for the first time, we have real data coming in, and we're seeing real suggestions. Other data is being used as well. Like you see John Doe up here. It used to say student. But now this is from our sort of the fixture data on our back end. So this is now coming through our GraphQL API. And we can see in our network tab, if we like, see this in action, just to round it out. Here it is. There's that GraphQL request and response. Sorry, it is a post request, of course. So here is the request payload, and you can see, we have an operation name. We have the stringified query. This looks a lot like, I'm going to highlight the one below it because it's easier to see. This here looks like this. Query, get current user, query, get current user. So there it is. It's just literally that string. And here's the response we get back. Data, there's current user, there's suggestions. So this is how things are working behind the scenes. We don't need to worry about much of this because it's all happening between Apollo client and Apollo server. So great. Now we're at a point where our UI is consuming real data. We're going to get our database hooked up. We're going to wire up, instead of returning like purely fixture data, which we are right now, just remember in our resolver, in our query resolver, we're returning this fixture data for suggestions and this fixture data for the current user. Let's actually get this returning something from our database. So this should be pretty easy. We're going to replace the existing suggestions resolver with this. Get all suggestions from our database. And because we've typed this really well and we have this context object, we'll be able to grab this little DB variable with ease. And we'll know this is working if we see more suggestions in the UI. Well, let's use our dev tool first. Well, that's a good sign. We see 4 things now instead of 2. And in the UI, we see 4 things here. So this is now data coming from our database. And then for our current user, we can do something similar. So what we're going to do here is grab all users. We'll use destructured assignment to get the first one in the array. So we'll consider like the first user to be the currently logged in user. And if it's empty, if there's no first user, we'll throw. Otherwise, we'll return. The reason we have to do that, I mean, not only is it good to give us an actionable mode of failure here, right, with a good error message, but this is not a nullable field. Like current user, if asked for, has to return some value. So if there's a possibility of this being null, both the type checking and Apollo's runtime validation should yell at us about it. We can explore that here in a sec. So just replace the existing resolver with the new one. Let's test it real quick. Okay, now this just changed here. Let's get the creation date. Great. It's March 23rd, so it was yesterday. So this is data coming from our database. I don't think that the UI will change much here because the fixture data is in fact the same thing. But you can see this switched back. It's no longer John Doe. So let's see what happens if we remove this. So now we're getting yelled at a little bit, like DB user or undefined is not assignable to the type that was generated for this resolver. So this is where we're kind of being told, hey, look, this is not supposed to be a nullable thing. Like you're supposed to always return something here. So where we are right now is we have type checking working across our tech stack. Now, if we wanted to maybe make this nullable, all we'd have to do is go to our schema.graphql, remove this exclamation mark. It's going to make our UI angry, by the way, because it expects current user to be there. But let's go back to our server subproject, run our code gen again. And we might need to bounce the TypeScript server, the language server. I'm not sure why this is allowed here. What if I return null? Yeah, OK. It's willing to tolerate null, not undefined. But if I put this requirement back and code gen again, it should reject to the null. Yep, it already is. Null is not assignable to that type now. So we'd have to put this back and then add the guard to handle the possibility that it's not there. So we can see like the guardrails are up. We're being protected from, like there's one set of assumptions and one set of constraints that both our UI and our backend and our data persistence, like serialization and deserialization, like all of that is operating under the same set of assumptions that are defined in one file, which is a great place to be. So the next topic we're going to tackle is nested data and the idea of retrieving related records that have a relationship with some of the top-level records we've already dealt with. For example, this is the new schema we're going to add to our schema.graphql. And we have a new type we will introduce called user stats. This is where we're going to see tweet count, following count, and follower count. And where you'll see that appear in the Twitter UI is these three areas in the header. They're currently at 0. We need to provide some real numbers. So you can imagine these might be aggregated values that we have to go and retrieve from some other place. Maybe it's more expensive to go and retrieve them. And we don't necessarily want to grab all of that information for other people's accounts, right? Like these other accounts that are not the currently logged in user. So that's an example of something where we need that for up here, but we most certainly do not need it for every tweet. We're going to introduce the concept of a tweet, which is related to a user in that each tweet has an associated author. And tweets have a tweet stats object as well. So this is where we're going to get into the idea of sort of a top-level resolver and then cascading down into specialized resolvers that will take care of these nested objects. All right, let's grab this and drop it into our schema.graphql file. Here's my schema.graphql file. I'm just going to add this to the bottom, right? If there's no particular importance of ordering in this file, just do whatever works for you. And I think there's one other change we have to make, and that is adding a top-level query for the array of tweets. Normally, we'd want this to be retrieved on a per-user basis, but let's just pretend in this world, everyone sees the same tweets. So we're going to add this to the query top-level type. We're also going to add this is effectively a has-one relationship where each user has a user stats object. So we'll add that to the user type. Put that right here at the bottom. Great. That is the extent of what we need to do in terms of schema modifications. Now, just note, author and stats on a tweet are nullable fields. They do not end with this exclamation mark. Same is true for this stats field. This is what we need to do if these fields are populated on an as-needed basis, right? In order to sort of save the effort of abstaining from getting that data and putting it together, they need to be nullable, right? All right, so the next thing we're going to do is add some more objects to our context object, right? This is the thing that the database is sort of held on, and it travels along into each resolver and gives us access to all sorts of different things. We're going to create some little caches. So let's open up our Apollo server.ts, and let's go down to where that context is defined, which is right here. And we're going to add some new things. We'll call them db tweet cache, and it'll be an empty object. And then we're going to have another empty object, db tweet to favorite count map, and then db user cache. All right, so we're getting a little type error here. It's telling me object literal has properties on it. And object literal may only specify known properties. Does anyone know why we're getting this kind of error? What's the purpose of excess property detection in TypeScript? Let me put it to you a different way. So let's return this object. Let's like make our arrow function a little bit more explicit. This means exactly the same thing now. And if I were to do this, the error goes away. It's kind of interesting the way that happens, right? In many situations, just sort of taking a value and holding it in a variable, that doesn't affect much of anything, right? We would, almost every other type error we would see continuing to appear. We wouldn't have meaningfully changed the situation. However, for this particular type of error, the problem has to do with TypeScript. Well, the thing TypeScript is warning us about is these three things are not on the tweet resolver context interface. And if we return this object literal, anyone who's using this value, they're not going to be able to safely access these extra things that we have. So it's sort of like we're creating this, and it's almost guaranteed that you'd have to do some dangerous thing like casting downstream in order to access these. Now, if we hold them in a variable like this, now it's, in theory, down here, I could access this, right? Like there could conceivably be a purpose for me using this in some way, right? Because I can pull it off the variable, even if things outside the function can only access db, because that's the only thing on this interface, right? So that's why excess literal property checking kind of goes away when you hang it off of a variable. But in any case, we should solve this in a more reasonable way by adding this stuff to our type. So we're going to go to resolvers.ts, and we're going to define the types for these things. And all of these will be records. So we've got a record of db tweets, a record of db users, and then this last one, the long name, tweet to favorite count map. This is going to be just a simple string to number. All right, so how are we going to end up using these? Well, first, let's see. The errors went away. These things are present on the type. These are no longer excess. They belong to this interface. Like we're just adhering to the contract. In fact, if we were lacking these, we would get errors, which is just as it should be. So what are we going to use these for? Well, there are some situations where, and there's a situation we may run into in a moment, where we could run into what's known as like the n+1 query problem. So let's imagine we're getting the list of tweets, and in order to do that, we have to figure out authors of all the respective tweets. And let's say that we have 100 tweets all by the same author. If we do this in a naive way, and we say, first we grab the tweet, and then we get the user ID of the author, and then later on we'll query the database for that author, well, we could end up going to our database 100 times to get that one record over and over and over again. So what we want to do is kind of pre-fill some information, reuse things if we can, and this is where we're going to hang things so that as we move through different resolvers, we can take advantage of the fact that we've sort of primed a cache with some data and save ourselves from hitting our database too hard. And at that lower level, you may not have the context to know whether it's appropriate to use the cache or to make a query yourself. You can just sort of use something that's there if somebody who knows more put it there for you, if that makes sense. So that's what these two are going to be used for. Tweet to favorite count map, this is like a similar intention, but rather than saying, here's a tweet, go iterate through all of the favorites in the database and count how many pertain to this tweet, right? That's a full iteration through all of our favorites. What we can do is iterate through all of the favorites at once and create a map of like this tweet had 6 and this tweet had 4. We can do one pass through the array with sort of a array.reduce and just tally things up in the appropriate buckets, and then downstream, we already have the counts ready to go. So that's the purpose here, to do a little bit of work ahead of time and save ourselves from excessive querying. The next thing we're going to do is introduce what I call a transform. And this is not a formalized GraphQL concept, but I think every code base of the kind that we're building here today involves something like this, and it's nice to sort of put it all in one place. What I mean when I say transform, it's something that converts from the database representation of an entity to the GraphQL representation of the entity. Just think of it as like if there were private data on a field or a slight difference in naming, and I think we have one in our app where the database thinks a tweet has a field called message, but the GraphQL schema, if I recall, calls it body. So that it's just, we need to do a little mapping here. These are just very simple back-end to front-end mapping functions. And they shouldn't do much more than that, because often you need to reuse these over and over. So I'm going to call this transforms.ts, just create a new module for this purpose. And we will introduce our first transform here, and this is for a tweet. So let me grab the code for that.
Someone in chat mentioned the adapter pattern.
The adapter pattern, yes. We have some fans of the Gang of 4 book in chat. This is, yeah, I guess it could be considered an adapter. When I think about the adapter design pattern, that's usually something that plugs into a larger object where you're not using the adapter directly, but you provide it. It's kind of related to the strategy pattern. So a cleaner example of the adapter pattern might be in our Apollo server when we're loading a schema. There is this pluggable file loader thing that we can give this load schema sync function. We don't know what load schema sync is doing, but based on which type of file we're loading, there's a different adapter that we can provide on a per file type basis. But we're never invoking this thing directly. That's kind of what I think of when I think adapter. All right, let's create our first transform. Sorry, let me reorganize my windows here because I keep sliding back to that other one. There we go, perfect. So here we go. This is going to transform a tweet. We'll take a database representation of the tweet. You know it's database representation because the type begins with DB right there. And what do we omit? A tweet, which is part of our generated code. So we know that this is a GraphQL entity of some kind. And we're omitting a field called author. Why? Because author's a related record. That's a field of type user. And that's going to require its own transform, right? We don't want this thing to do anything more than transforming sort of the most basic and primitive data that relates to a tweet. So let's grab this whole thing, drop it in that newly created file. And we see an error up here. That means we kind of need to rerun our code gen. Remember, we've touched our resolver. So we're going to need to build up our representation of the GraphQL schema in TypeScript. I'm being lazy here. All right, new types came in, error went away, we are good to go. And see, here's an example of a nice little mapping here that's kind of important. Body versus message. This is a good time to do that. And there might be things on this that we don't want to pass through. So cool. So there's our transform. Next, we're going to want to import this into our query resolvers, and we're going to create a tweets resolver function. So let's go to our query resolver, add this import, and then we will get our tweets resolver function. And here it is. And we'll just add it right here below suggestions. All right. Now, I'm just to be safe, I see that ESLint is bugging me here. I think it's probably just not caught up with the latest changes to the types. I'm going to restart ESLint real quick. And we'll see if things go away. Seems good. All right, let's talk about what does this code mean? Right? We just pasted a bunch of stuff in here. I want you to understand what's going on. So first off, this is a resolver. And this is a good time for us to talk about the 3 arguments that a resolver is passed. This here is known as the parent. When we get into cascading in resolvers, right, like the idea of tweets have an author, and we resolve the tweet, and then we have to go deeper to resolve the author, this will become more clear. But just think of it as we're at the top level here, right? We're right in this query resolver here. So parent isn't going to be especially useful for us in this context. We're right up at the top. There is no useful parent for us. This argument here is args. This is where if we accepted parameters here, which we will get to soon, this is where we would find those parameters. Like if I was requesting one tweet and I needed to provide a tweet ID or the favorites associated with a particular user, this is where I would get my user ID. It's where those arguments, come in. And then this, of course, is the context object. This is where, we can hang useful things, and it's sort of this little scratch area that because of the way we've used context, we've defined context with a function, right? By that I mean this function here, right? We're going to get this function invoked every time a request comes in. We'll get a fresh empty area. We can put whatever we want in there, and then once things are returned to the client, that goes away. We start fresh next time. So those are the things that a resolver is passed. Now, what are we doing here? Well, we're calling db.getAllUsers, and we're iterating over all of the users, and we're putting them into a cache. Why? Because as we're assembling this list of tweets, we're going to have to go and look up the list of authors, and we can very easily just sort of put them in memory, and then sort it out down the road without having to hit our database. Now, you could query your database each and every time, but I would advise against that. In a more realistic scenario, what you would probably do is retrieve your tweets, get the list of user IDs associated with the authors of those tweets, and then prime your cache with that subset of users, right? But it's often way cheaper to make that one query where you're getting a collection of things back rather than a bunch of little tiny queries in a loop, because like that, without, I mean, it's just a lot of round trips, and even worse if you're doing them sequentially. All right, so here, DB2favorite count map. So in our database, we have a concept of favorites. Let me look at my schema.graphql. We have not defined a favorite type here, but just think of this for now as a many-to-many relationship between users and tweets, right? Tweets can have many people who've liked them. Users can like many tweets, many to many. So it's sort of, you may have heard of this concept of a join table. This is like a record in a join table. So just think of it as like, it's something that holds a tweet ID and a user ID. Let me show you what this looks like in the database. Here you go. Tweet ID, user ID, some timestamps, and an ID in and of itself. Like it's just sort of an edge in our graph, so to speak. Now, we still, in order to get our stats, right, in order to produce this object, even though we're not exposing favorites as an entity through our API yet, we're still going to need to count them to complete this part of the exercise. And we need to just come up with the right integer for now. So we're getting all of the favorites, and then we are getting the current count, right? If there's an existing count in this map for the tweet ID, we use that. Otherwise, we start at 0. And then we increment the count by 1 and put it back into the map. So effectively, this map starts out as empty, and then we're counting starting at 0. And so eventually, any tweet that has likes of any kind, that will show up in this map. So we'll have tweet IDs and then a number. All right, then we're going to grab all the tweets. We're going to map over them. We're going to cache them, and then transform them and return them. So ultimately, what we're going to end up returning is the GraphQL representation of a tweet, and we will have cached information about how many favorites each tweet has, all of the users, and all of the tweets. Let's see what happens. So I'm going to go to my DevTools here, and let me clear this out. Start fresh. Note that Apollo Studio is polling your API every so often, and it's already picked up on the fact that tweets is a new query that's available. So I'll just click this, and what do we want here? We want body, and then author, name, handle, something like that. Let's run this. All right, so we've got the body. Great. I see a lot of different body here, a lot of different tweets. Author is null. And the reason it's null is because we haven't done anything with author yet. And it's a nullable type, so this is fine. Now, there are two things that we could do in order to make this work. We could either, in here, as we're transforming this, we could say like author. Let's do this just for fun. This is temporary code, so don't bother to copy this in here. So I'm gonna borrow the code from our current user resolver, just so we have access to this first user. I could do this. Unreachable code detected, because I don't want to return the first user. This is ESLint complaining again. I'm just going to bump it, restart it. OK, so REST spread properties are not. I promise I'm using the right version of Node here. All right, we could make this happy. Fine. Fine, if you want me to do it the old way, I can do it the old way. Object assign. So if we save this, we're effectively merging these two objects together. Let's see what GraphQL Studio says. Hey, look at that. Authors coming in. So one option we have is to eagerly populate this thing as we're deserializing this tweet object. But let's say that we don't want to do this, because this would mean even if you didn't ask for it, depending on whether the query is requesting this particular field, it would either be dropped away or kept. But let's say that we want to refrain from doing that extra work unless we really need it. So I'm going to back up here to this point. And this is where we should see a null again. And we do. So now it's time for us to create a new resolver. And you can create resolvers that are on a per type basis. So we're going to create two new resolvers on a per type basis. One's going to be called user.ts and one's tweet.ts. We're just going to finish up the back-end work here before we move to the front end here. So on the website, you can see that we have, in this inner resolvers section, we've got our user.ts resolver. Let's paste that in here. And then we'll do the same thing for tweets. We'll look at this code real carefully once we paste it. All right, an auto format if you like. All right, one more thing we have to do, and that is in our resolvers.ts that sort of stitches everything together. This is where we want something like this, user and tweet, and we want to import those here. Just like that. So what I added were these import lines, and I just sort of, I'm assembling them all together. You're trying to match what the schema looks like, right? Where you've got query, you've got user, you've got suggestion. You know, you don't need to have all of them necessarily, but anytime you're doing what we're about to do with these nested, deeper fields, you will end up doing something like this. But the structures of these things should match. OK. And everything is type checking properly now because, remember, we ran yarn code gen immediately after our schema changes. So finally, I want to talk about the code that we just pasted. So let's look at our user.ts. So this is for stats, right? This is like user stats. This would be the stuff that's at the top of the Twitter UI, this stuff up here. Following, followers, tweets. These are 3 counts. And you can see we're faking 2 of them just because I don't want you to have to do repetitive stuff here. And we don't have the concept of following in this model. So we're just putting a fudge number there. Here we're saying get user tweet. So that gives us an array of tweets. And we get the length of that list. And something new here, this first argument, user. So what's happening here in terms of the flow of what's calling into what? When you make that top level query for current user, if someone has requested stats, this will be called first, and then whatever this returns, when you get into this user.stats thing, you'll have whatever the top level resolver returned. You'll have access to that. So that's how we're able to call user.id. Now, we're making a call to our database here. I don't think this is a problem because we're getting the current user once. This is not something that's happening for each tweet. We're not requesting stats there. This would be a problem if, we're doing this 100 times. You could end up with 101 database queries. 1 for every stats and then 1 for the user, right? Or sorry, you'd have 1 for every tweet and then or one for the list of tweets, and then on a per user basis, potentially one or more queries. It would be pretty awful. So, but in this case, this is appropriate, right? And we're just getting this array, getting its length. Let's see what happens in our Apollo Studio. So we're going to ask for current user, stats, and let's get everything that they have there. So just to format it real nice, boom. So we haven't tweeted at all with this user, which is fine. This is to be expected. And here are the numbers that are coming out. I see a question in chat. What did I put in app.tsx? I have not touched my client-side code quite yet for this step. So we can consider the back-end work pretty much done. But let's talk about the tweet stats here. So we'll want tweets, body, stats, and let's just do favorite count. Run it. So we see different favorite counts here. We see 1, we see 4, and here is the body coming through. So this is evidence that we're actually counting stuff up in the back end. We can get even more confidence about that by sort of picking apart this thing we pasted into the tweet resolver. So first off, here's our stats thing. Here's us using this tweet to favorite count map just for fun. Let's log that out. Let's see what it looks like. Fire it off. And look at that. We've got tweet IDs and then numbers. So this is the result of us looping over them and sort of just counting them and incrementing by 1. It's no database call required for this. And so it's absolutely fine to do this for each record, right? So that's all that's happening here. Nothing too fancy. And again, because this is sort of a sub-resolver, we see the parent object here is available for us, which is what we need so that we can use the proper ID, right? This is called for each tweet. So let's get that out of the way. What about the user, the author, right, which is of type user? So this is where we can grab the tweet. And note that I am using this DB tweet cache. So this is a common issue, right, that we're trying to solve. The GraphQL representation of this object, when we say author, what you expect to find there is an object that represents the user. But in the database representation, let's see if we can go to the type definition here. Oops, wrong type definition. I want the DB tweet. Here we have a user ID, right? So it's like the idea of, are we referring to a user or do we actually have a user? That's why it's important for us to have access to this database representation of the tweet. This tweet here is missing its author. It is our job, in fact, to go and find that author, right? Tweet.author right now would be null. So if we have this, lower level record that just has the user ID, that's what's going to let us grab, the user ID here and populate it. And again, we're throwing wherever we find that something's missing because this is a non-nullable field. Or sorry, this is a nullable field, but we want to make sure that we provide something reasonable in the case where it fails. So that's all this is. We're just using these two caches. No database queries here, because this is going to be to support a list of tweets, and these will be called many times. All right. So that's all of our back-end code. We've walked through all of it. In this next step, we're going to consume this data in the UI. The first thing we'll need to do in the UI is we'll open up our app.tsx, and we'll look at the GraphQL query we have for getting the current user. We're going to add something to the current user piece of the query. And you see I get a nice little autocomplete here from the GraphQL like VS Code extension. So I want stats, and I want all of these in there. Follower, following, and tweet count. And it turns out that the fact that this was missing here, that's what prevented us from getting fully away from our fixture data for the current user. So if we were up here, you might notice, oh, I guess this is also missing it. In any case, you know what, I think that that's why everything's falling back to 0, because this was missing in the first place. In any case, we can start wiring this through that header component that we have, and we should start seeing those numbers are no longer 0. So let's get rid of anywhere that we see this current user, or just in this one place for now. Let's pass this instead. So this should have real data. And let's check out our UI. It's still 0. Oh, you know why it's, well, no. I was going to say we haven't tweeted yet, but I should still have followers, huh? Let's log into the console and see what's happening. Sometimes there's a little caching issue, or you have to stop and restart things. There's current user. And interesting, I don't see stats coming through. You know what it could be? I wonder if we code genned on the client side. That would be the first thing I'd want to try. I'm not getting a type error, but it's worth a shot. Because we did just add this here. That could cause this problem. Oh, there we go. That was it. So remember, the code generation, especially on the client side, it's not just about types. It's also about that function and making sure that it's building the GraphQL query properly. So it's important that you do that, even beyond just the type checking aspect. The next thing we're going to do on the client side here is wire up the list of tweets. So remember, we have that tweet top-level query up here. This is something we just added in the previous step. So we're going to actually consume that and start to get away from that fixture data, the currently hard-coded list of tweets. So the first thing we have to do here is go to a timeline React component. And you can see here, this is our fixture data. This is timeline.tsx. We're going to add a new GraphQL query that represents fetching this data. And we can get rid of the fixture data, by the way. We're going to replace that. So let's go to the course website. Let's scroll down to this tweets section. And here is the stuff to add as an import. Right, since this is the first query that we're using here. Put that up top. And the new query. And of course, right after this, what are we going to have to run? Because we have changed the GraphQL stuff. Code gen. We're going to have to code gen again, so that the types for this are built. Great. And this type error should go away shortly. Well, now it's just telling us we haven't used it yet, which is great. OK, we have some more stuff to add right within the component. So again, we're using this hook, which is built on a per query basis. It's part of what's generated for us. The things it returns are a loading state, an error if one exists, and then ultimately the data that will come back. This will be truthy once the data arrives. So we're returning some trivial feedback here in the event that things don't look like they're going well. And then if we look like we have some data, we can destructure it, get the list of tweets. So I'm going to paste this in before the return within the component. So just some really simple feedback here. You would want a much better error handling experience, but I don't want to make this any more complicated than it has to be. So by the time you get down here, tweets is of this type. It's not a null. It's definitely going to be an array, and the array is going to contain non-null things. So perhaps we can just iterate over this. Let's replace this capital tweets with the tweets. And if that's ESLint bugging me again, I will just, yep, tell it to shh. All right, and let's save it and look back at our UI and see what happened. We have some more tweets here. So this is stuff that's actually coming from the database, and this is evidence that we're really wiring this app up. We're starting to remove the fixture data and power it with real things, all through the GraphQL API. The next topic we're going to deal with is this concept of mutations. And if you think about the equivalent in the REST API, mental model, this would be put, post, or delete requests, things that actually write data into a database. And the first thing we'll need to do is add a mutation to our GraphQL schema. Like query, mutation is a top-level collection of resolvers, and we're going to need to create the equivalent piece of our schema. So I'm just going to copy this, and I'll paste it into our schema.graphql. I like to keep these up at the top because when I'm trying to reason my way through how things flow from, like, for example, before we were dealing with tweets, and then it goes down to sort of tweets.author as a separate sub-resolver. I like thinking about things in terms of top to bottom. So let's look at the create tweet field in this schema. We can see that it looks sort of like a function, and that is because this is the first situation where we are taking in variables. You can think of these as arguments. So looks very similar to TypeScript syntax in that we have variable name and then the type, and then variable name and then the type, and this is the return type. So what this is going to amount to when we start using this on the client is it's going to be kind of like we call a function called create tweet. We pass in a user ID and a body, and we get a promise that resolves to a tweet. As everywhere else, as is the case everywhere else, these exclamation marks mean this thing cannot be null, both in terms of the variables passed in, they cannot be null, and you can rely on actually getting a tweet back, not nothing. So there's our schema alteration. Now we need to create a new resolver to go along with this new type. So let's open in our server subproject the resolvers folder, and we're going to create a mutation.ts. And there is some code on the website that you can copy and paste. Here it is. As usual, let's paste it in. Let's talk about it. All right, and let's run our code gen here because we of course changed our schema a bit. So I'm going to run it in the server subproject and yarn code gen. Got to see the green check marks. That's great. This looks like implicit any issues. Let me just give it a sec. I'm going to just restart TypeScript server. Let's see what happens. Hey, that looks better. All right, and what's going on here? That's ESLint. Let's bump that. Bump all the things. Good, no errors. So let's study what's going on here. So first, this is the first case. I told you it was possible, but this is the first case where we're actually doing it. An async resolver. Right? We're taking advantage of the fact that create tweet either needs to return a tweet or a promise that resolves to a tweet. And when you're dealing with mutations, where you're actually writing something to a database, this is where async usually is most likely to happen. When you're getting data from a database, sometimes it's something that happens synchronously. You don't necessarily have to make sure that an entity that you just persisted exists before moving on. So this is where, we're waiting on something to happen. All right, so here is parent. We're not using that. That's why we have an underscore before it. Args, this is the first time we're taking in arguments. And you can see that the type of args has this body and user ID field. Those are coming from here, user ID and body. So you may think of these, if this were a function, right, these would be local variable names. They only have a meaning within the function. Here, these are more like query params. So their name is significant. And whatever these names are, that needs to be consistent in your server-side code when you're plucking these off, this args object, and in your client-side code when you're providing those variables in the query. These are the names that you're going to use. So name them carefully. They have to have meaning. And it's part of your public API where if you change it, you might break people. But thankfully, in this situation, you'd get type errors all over the place, which is helpful in terms of helping you refactor. So those are the args. And because they're non-nullable, we know that they're both going to be a string. Next, we use db.createTweet, which returns a promise that resolves to a db tweet. So it's going to persist it, and then it's going to give you back this entity that was just persisted. This does a little bit more here. Is this ESLint again? Yeah, let's just ignore that. So this creates timestamps so that right before it's persisted, I probably should have created one timestamp and serialized it twice, but you're going to get 2 dates, stringified, and then an automatically generated unique ID. So you don't have to provide those. This is a common thing for a database to do, right? You don't want to feed it IDs. It creates the IDs. So there you go. We'll end up with our db tweet after awaiting. Next, we have a tweet map. So we're going to reuse this same caching object that we can put these entities from the database in so that downstream resolvers can do their job. In this case, remember, tweets have authors, and even after we persist this thing, in order to return it, that tweet.author resolver, that's this one here, this is still going to be called. And so we need to make sure that db tweet cache and db user cache have the right things in them. Now, thankfully, we'll know when we pull out what we hope is cached in there, we will get a nice error in the event that something's missing. And by the way, if we remove this, note that we have db user or undefined. So we're using a recent compiler option here called no unchecked index access. It's a TypeScript compiler option that says whenever we use like square bracket notation, the type of the thing that comes back always has the possibility of being undefined. Because this, we're hoping something's in there. If we did our job, something's in there. But we're obligated to make sure that what we got back is truthy before we go and continue to use it. So that's part of the reason I'm doing this, and it's exactly what you would want if you're using this as a cache, right? It would give you that great feedback. And in this situation, you could also fall back and say, all right, nothing's in the cache. Let's actually hit the DB and let's get this thing, at least we can get the data, right? Cool. So we're going to populate the tweet map, and we're going to transform the tweet, and we're going to return it. Seems good. I actually noticed that we have a little bug in here. Now, we could complete this exercise even with this bug, but I'm going to fix it. And that is, we didn't put the author in the author cache here. And I think we would get around this because we're not actually returning. Like when we're making this query, we're not getting the author back. That wouldn't be too bad, though. We could say object assigned tweet transform, and we'll put in author You don't have to do this. I'm just doing it for completeness sake. So we've already got the user ID up here, right? This is something that we were given as an argument. If the author is not found, because we're getting by user ID, and that could, does that already guard us here? Looks like it's pretty confidently returning us an author. We should do it anyway. And we'll make a nice little error message here. Again, don't feel pressure to copy this down, but I'm just sort of improving it on the fly. And then here we would say transform or user transform. Do we have this? I guess we could just pass in the DB author here because it doesn't need to be transformed yet. Don't need that await. All right, so now, now we could be assured that the author will be populated in this case. And that means that user.author, this resolver here, well, sorry, we never had one here. Tweet.author. Tweet.author will never be called because when the tweet comes back after that first resolver, we'll already have this thing in place. It will already work, and we should be good to go. All right. So one more thing we have to do, which we didn't do before, mutations. We need to hook it up in our big collection of many resolvers. And we'll just follow the pattern up here. Right, so all of the resolvers are sort of joined together. And I think we should be good to go. Now we could try to create a tweet. I'm tempting fate a little bit here. Just want to make sure my database has no changes in it. Great. So if we screw things up and we put a value in there that's not reasonable, we can always revert that JSON file and get into a good state. So let's try to do this using the dev tools, just because it's good to know how to do this in case you have to in the real world. So we've got at the top level root types. We have a mutation. We have create tweet. Note on the bottom, there's this new little area that just became useful. It's got user ID and it's got body. So we're going to need a real user ID. And we could get that with GraphQL, actually, if we get rid of this. Let's make a query and just get the current user ID. Boom. Query. Awesome. There's the string. So let's paste that down here for user ID. And then say first tweet. All right, and now let's go back and let's create that mutation query. Here we go, create tweet. And what do we want back? Let's just get the ID back. Boom. All right, we got a tweet ID back, and let's see what happened in our database. There's db.json, and there it is. So that's us testing our first mutation, the creation of a tweet. In this next part, we're going to modify the React component called Compose Panel. That's where you're actually going to type this tweet, and we'll use this mutation that we created in the previous step. So let's open our client-side project, subproject, and we're going to go to composepanel.tsx. And in here, we're going to import some utilities. The Apollo client's GQL tag, and something that will fail at first, the React hook for using a new create tweet mutation. So we're going to add these up at the top. And we're going to have to grab this mutation as well. Note the word mutation here. This is different from query. Like this is important in terms of wiring things up the right way. But otherwise, looks quite similar. And we'll look at that in more detail momentarily. All right, so note we have these $ things, create new tweet, user ID, and body with these $signs. So these are the variables coming into your mutation. And then you could have potentially more than one of these things that uses the variables, right? So this is the idea of like having a mutation and then variables, and then they can be doing more than one thing down here, which is important if you wanted to sort of almost create like a transaction of sorts where many things are happening at the same time. You want them to be going on concurrently. It's not strictly a transaction in that it depends on your implementation and your resolver whether you let it to either complete as one atomic operation or not. But in any case, it's sort of going to be one promise from the standpoint of the consumer of the API. And this is a nice little aspect of the VS Code GraphQL plugin. You can hit execute mutation, and it's going to ask you for, the variables, the value for user ID, the value for the other thing, and then the response would show up over here. But I'm not going to bother doing that. Yeah, here's the error from our server. Nice to be able to do that right from within your code. So great, we have the new operation in our UI. That means we have to code gen again. In the client project and yarn code gen, show me some check marks. Great. At which point this, red line went away. Now it's just unused. And we can see here's the type. These are the variables that it takes in. Looks like everything's flowing through as we would hope. So the next thing we'll do is delete the whole thing. We're going to replace it with the hook equivalent. In fact, Copilot is correctly suggesting it to me. There it is. Create new tweet. And then there's a second argument that we can capture here, which is error. And I believe there's a loading property here as well if you wanted like a little spinner that would render while you're persisting it. It's going to happen so fast in our case that it's not even worth worrying about. So that's the first line. And then we can say if error, this is on the website code if you want to just copy paste it, return p error creating tweet, and then we'll have the error, something like that. Right, so there's your hook. And we're leaving it with the same name. Should be OK. And we're going to have to just change what's happening at the call site. So handle submit, this is actually what's wired up to the DOM event here, right? This is the form submit event. This is our invocation of create new tweet. This is where things are actually happening. In this case, we just console logged, and then this was like the placeholder implementation. We'd log and say this is where we would do the thing, and then we clear the text area so that the composed tweet goes away. Well, in this case, what we're doing is going to be async. So we're going to need to change this a little bit. At the very least, we'll have to say, .then, and then clear the input or the text area, something like that. Right. So and let's bounce ESLint. The other thing is we're not just passing in body here. We're passing in something that this GraphQL React hook is designed to receive, and that is a variables object. So there's this config object. For now, we're just using variables, and we'll pass in user ID, and it's going to be current user ID, and then body is something that we're already getting here. We have a dangling promise here, which is bad juju. So we want to add a catch block. Something like that. So just in summary, we created our new mutation. We replaced our placeholder, create new tweet function with the use of a hook. We're handling this error in the case that things go wrong. So this will happen after we attempt to persist things, maybe our server goes down in the back end, and this little text will show up, which is great. And now we're changing the way we're invoking this. We're not passing the body in directly. We're passing in this variables object, giving it the user ID and the body. Again, in our schema, there's user ID, there's body. So these are not local names. They are part of your public API. And then we're clearing things out in the event things complete successfully, and we're erroring in the event that things go wrong. Let's try this out. Let's see if it works. Yeah, so I got a question in chat. Is error unknown? You know, it should be. These days, I should really make sure it's an unknown. I wonder if, you know what? I would have to type it here. So there's a new TypeScript feature that makes it so all values you encounter in catch blocks are unknowns. But this is literally the catch type of the promise API, so it doesn't really benefit from that. However, you are welcome to type it as an unknown. In fact, I think it's wise to do so. Yeah, Mark, you're correct. I did suggest doing this in the Making TypeScript Stick course, but that's for try-catch, the sort of the fundamental control flow JavaScript concepts. In the Promise API, I do not believe that those new language features carry through. In fact, I'd be surprised if I hadn't already set things up that way. Let's see. Yep, use unknown and catch variable. So I already have this turned on. It's sort of the async version of it. If this were a real try-catch, you would see it. But that's the right instinct. People who are like thinking, make that an unknown. Good, keep that. All right, let's kick the tires, see if things work. So we should be able to, let's refresh, just make sure we get the latest code. And hello, this is a first tweet. By the way, this is from 9 minutes ago. This is the stuff that we persisted through the dev tools, so that's showing up. And I'm going to hit compose. Boom. And we see nothing. The text area gets cleared, and we see nothing. And if we refresh, there it pops up. Less than a minute ago, this tweet was created. So what's happening here is we are successfully persisting the data. We can see it. First off, like when we reload, we see that the data comes back. In addition, if we look at our changes, we can see this just happened. What's the current time? It's 37 minutes past the hour. That's probably this one here. This is my first tweet. So it's persisting, but what's happening is the state in my React app is not updating. Now, normally you would do this through some state management library, or you would use set state or something like that. There is another option in the Apollo world, and that is the idea of refetching the data associated with a particular query. And that can happen in sort of an action at a distance way. So although we're in this compose panel and something just happened, the data we want to effectively like invalidate and refresh, that's in this timeline.tsx file. It's this query here called get timeline tweets. And in terms of how these are organized, compose panel is a child component of timeline, right? It's within timeline. So it's a child that wants to sort of tell its parent to reload. Many different ways to do this, but I want to show you, this is a good opportunity for me to show you how you can do this just at the Apollo layer. So the way we're going to fix this bug is adding a new option to the way we're invoking this hook. And it's going to be refetch queries, and we'll pass in an array containing get timeline tweets. So this is what's exported from timeline. Remember, we're exporting all of our queries here. See, we're bringing it in up here, and we're just saying refetch queries, get timeline tweets. So when this comes back, it'll say, hey, this something just happened, and that something seems to feel that you could get something different. So why don't you go ahead and refetch this? And behind the scenes, what's happening is a set state. And that's causing the timeline component to refetch and update accordingly. So I'm going to save this real quick. And let's go ahead and test the UI one more time. I'm going to refresh, make sure I get the latest stuff. Does this automatically work? Will we see it right away? And we do. And in fact, oh, interesting. The tweet count isn't changing here. If I refresh, it is changing. Actually, we could fix that as well. We just need to, it's getting a little heavy-handed here. We could refresh that get current user query as well if we wanted to. Let's do that. If you're feeling like this is starting to get out of hand, fair point. No more refetching. And we can hit this. Now, are we going to see the tweets count go from 3 to 4? Yes. I love boiling the ocean. It makes so much steam. And 5. Action at a distance is a little dangerous because you have to think carefully about how you'd be able to debug this kind of thing. And what you don't want is a situation where someone's performing some interaction and it's causing mysterious side effects to happen elsewhere in the app. So use it like salt. A little bit goes a long way, but this is a nice, in the case of the timeline tweets, this is, I would say, a straightforward kind of thing to do. And it certainly beats the idea of trying to shove some client-side representation of that data structure, which might not have a timestamp on it or an ID or whatnot, trying to shove that into an array and optimistically update the timeline. Like, I would prefer just get the new data, right? Nicholas asked a good question in chat. Maybe we need idempotency. So this would work very well with, so the idea of idempotency, it's a very fancy word that means effectively like performing an operation more than once with the same inputs will turn out to be a no-op. So a lot of this has to do with like writing code in such a way where your code just wants to reach a given state, and if no work needs to be done in order to get into that state, no work will be done. This is how React does its rendering, for example. In this case, I wouldn't argue that we're doing things in an idempotent way because we are fetching a lot of data that we might already have, if that makes sense. So we are doing more work than we need to. Yeah. All right, from the classroom, Mark asks, can current user summary and the tweet list subscribe to changes somehow? It feels like Compose panel knows too much about other components. I could see how you would feel that way, right? Like the Compose panel is reaching up to its parent's query, and one could argue that that sort of breaks the separation of concerns. GraphQL does support the concept of subscriptions. I'm just going to kind of show you what that looks like. So here we go. You can create a type called subscription. It's very similar to query and mutation. It's one of these special top-level types. Here's the thing, though. You know how GraphQL supports querying and mutation, but it's totally on us to implement the actual work that is done. We're touching a DB, right? So the trick is not necessarily like, is it possible to use subscriptions with GraphQL? Absolutely, it is possible. But you get into the same problem that other near real-time apps run into, which is there's a significant overhead for each user that's connected to your app, right? Be it through a WebSocket or long polling or anything like that. It makes sense if you're building like a chat app and you want to know when new messages arrive. But if you do it for all of the data that's in the UI, it's just a lot, and it's expensive in terms of operating that system and making sure that it's performant. So I would say, yes, it's possible. Be careful. The problem GraphQL solves in this space is not the hardest problem to solve in this space. And the hard problem is, how do you do this in an efficient way, and how do you use this near real-time update sparingly in the right cases where it matters? If you're building like a stock ticker app or a currency trading app or an eBay, and you want to show the auction countdown and you want that UI to update and for that to be definitely how much time is left because someone's making a purchase decision based on that, that sounds like a valuable place to use this kind of thing. But I don't know if I would use it for a Twitter clone. Nicholas in class points out that the client could also provide the count value that should be updated. So I assume what you mean is, like, at the time the compose panel submits the tweet, we could just say the count is incremented by 1. Yes, of course, we could do that. But I'm not sure that I would advocate for doing things that way, because what if the user has multiple devices and they send a tweet from their phone and they have had this page open on their browser for a week? It's kind of just there. They keep it on their third monitor, and then, I want this state to kind of come from the source of truth. I don't want it sometimes to come from my back end and sometimes to be coming from my front end. That can result in a confusing experience sometimes. The next feature we're going to add to our Twitter app is the concept of favorites. And this is going to involve 2 mutations because we're going to treat favorites as its own resource. It's sort of a many-to-many relationship where you can think of a favorite as the join table, something that refers to both a tweet and a user, where a user can like many tweets and a tweet can be liked by many users. That's effectively all this is going to be. We're going to have to create these favorite entities, and we'll have to destroy them when a user unlikes. So we'll get practice building 2 more simple mutations. The first thing we're going to have to do is add a little bit of code to our GraphQL schema, one more type for this new favorite entity. So let's copy that, open up our schema, and paste it right at the bottom. So note that favorite has a relationship with tweet and user, and those are non-nullable, meaning we're going to have to populate those anytime we're returning a favorite of sorts. Next, we're going to have to connect this concept of a favorite to user. So here we go. Let's just put it right here at the bottom. So a user has a field that's an array of favorites. So can somebody help me think about whether it's possible to have nulls in this array, or whether it's possible for me to get null back instead of an array? Is the collection nullable? And second question, are members of the collection nullable based on the schema?
Collection's nullable.
And the second part?
No. No.
The collection is nullable, so favorites could be null instead of an array. But if you get an array, you can rely on the fact that everything within the array is of type favorite. That's what this exclamation mark means. Great. You may also note that we have, like, favorite refers to a tweet. But in this case, tweet does not refer to favorites. This is actually fine. This means that Potentially, when we're pulling a tweet, we don't want someone to find the list of users who have favorited it. Maybe we only want to expose that information through the stats object where you get the count of the favorites. But, maybe in the future a product manager comes along and says, oh, we want to show the little face pile of like all of your friends who have liked this thing. Then we would need to establish that relationship. But there is no requirement that you need that symmetry in order to define the relationship. This is about your API's contract with the outside world, not necessarily a fully fleshed out diagram of how your entities in your database relate to each other. So it's important to remember that, because in some cases you don't want to expose more information than you need to. All right, last step that relates to the GraphQL changes. We're going to go to our app React component, and in this getCurrentUser query, we're going to retrieve the favorites array. So here we go. It's within current user. And all we want to get back is, so we want the tweet, and then within the tweet, we want the ID. So this is going to give us an array back. And each item in the array is going to be an object containing a property called ID, whose value is a string. Objects with an ID in an array. All right, time to run yarn codegen, because we've changed stuff on our client and our server. Yarn codegen, and then on server, yarn codegen, and everything looks good. So what this means is I should be able to, let me just test this real quick, make sure everything's wired up. I turned it from a value to a key just by adding more destructuring to the right of it, right? So here we go. That's what I wanted to see. There, it is objects. Sorry, it's more complicated than I even described previously. These objects have a property called tweet, and within that, like the value of tweet is an object containing an ID. So I did this deliberately because this is a common pitfall that people experience with React. As soon as I show you what this data looks like, you are likely to ask me a question. And that question is, how do I flatten this down? It seems like I just want this array of IDs, and I'm having to effectively map over this and drill in, and if anything's nullable as you drill in, you have to deal with that. GraphQL does not really solve that problem. It's going to give you data in a format that's aligned with the schema and aligned with the types. So I'll show you what I mean. I'll show you what this data looks like in its current state. Actually, we don't have our resolver. I'll have to wait to show you that. But that is a problem that GraphQL doesn't solve, and it's kind of a common complaint, that things get nested in a big way. All right, let's keep going here. So we made this change. Great. We ran yarn codegen on both client and server. Great. Time to add a new transform to our transforms.ts file on the back end. So let's go to transforms.ts and paste this in and pull these imports up to the top. This is a favorite transform. It doesn't do much, but it's good to have there. Organize imports, well it combined them for me, which is great. So that's all it is. It's everything about a favorite except for that user object and the tweet object. So it's just sort of passing through everything else. Next, let's go and import that transform into our user resolver. So it's in the resolvers folder, user.ts. And how are we going to use that? It's user.favorites. do the old restart everything. Okay, what does this code we just pasted do? You know what? I'm going to disable this lint rule real fast so that I can stop having to kick ESLint so many times. It should be reading from my engines property that my version of Node is not 8. I think I have to put that in here, overrides. That's for the server stuff. We're just going to turn this all the way off because something's weird. Okay, sorry about that little squashing of an annoyance. So what does the favorites resolver do? Well, it takes in a user as an argument, because the only way that this is getting called is if we've asked for user.favorites. In fact, it's safe because we're in user resolvers, like that top level user thing will always be called, like current user, right? Or tweet.author.user. But somewhere you're passing through a user to get to this. So we're getting the user favorites, and this returns an array of db favorite. Then we're mapping over them, we're transforming them, we're placing the user into the record. Remember, this is already the GraphQL representation. It is the already ready to go user that's ready to serve up the parent node in the graph. So we can place it right in there. And then the tweet, we can get the tweet by ID, and then we can do a tweet transform here. So we have our user and our tweet. And we should be able to make this work in our GraphQL Studio now. Let's give it a shot. All right, we have one favorite, and that ID, I have, to make it easy to see that we're getting the right things back, IDs always begin with a hint of what kind of entity it is. Let's add a couple other things, like tweet body. So there's, like, you can see a list of things. What are the tweets that I favorited? But let's actually go back and let's look at what we're really trying to gather here. This is what we're going to consume on the client. So it's going to be an array of objects that have a tweet property whose object has an ID property that has the string we're interested in. So this is sort of that deep nesting that can get exhausting at times. And there's really not much you can do about it. This is what we deal with when we work with GraphQL. It doesn't solve all the problems. And this is sort of, it's workable. You're an array.map away from getting what you want. So it's not too bad. But it does mean that there's some complexity in what you get back. All the more reason that having those types is important so that you can feel confident as you drill in. You know what's there, what might be there. And so you can solve this yourself more confidently. So let's jump onto the UI side and wire this up. We're going to be working in the app.tsx component, and we're now finally going to get rid of that current user piece of fixture data. So we're going to pass this directly into the left sidebar. And this is the only change that's not trivial. So we're mostly going to just replace this current user in snake case, all caps, with the value that's really coming from the backend. This is a case where we merge two things together, and this is where we can get away from that merge entirely because it's no longer necessary. So app.tsx, find all occurrences of current user. Actually, we can start by deleting this fixture data. Boom. And find all occurrences, replace with current user. And then we can get rid of this. This is nonsense now. Like, creating a clone of an object and mixing it into itself doesn't really make much sense. All right, finally, we're just going to have to reorder some lines. Why? Because we need this get current user query to kind of happen first before any of our destructuring happens. So I'm just going to kind of move the hook stuff way up to the top of the function, and everything should work nicely. let's check out the UI. So what we expect to see now that favorites are coming in is, I believe we'll see numbers next to the favorite count for every tweet. There's one favorite here, there's 4. This shows that I, as a user, I've already liked this one, right? Because that's part of getting that array of favorites with the tweet IDs for the current user. That's what I'm using as we go through and render the list of tweets. You know, is this tweet already favorited? Here's an array of what the current user has already favorited. Is your tweet ID in this list? If it is, you're favorited, right? So great. What we've just done is now this is live data. This is coming in and it's live data. What we have to do next is wire up the create favorite and delete favorite mutations. The next thing we're going to add to our Twitter app is favorites interactivity, by which I mean the ability to click that like button to like or unlike a tweet. So we're going to introduce a new concept here called an input type. And you can think of this as kind of a reusable object type that you might refer to in variables for your mutations or for your queries. So we'll add this to our schema. And let's put it up here, right below the top level query and mutation root types. And then we're going to add our 2 new mutations, create favorite and delete favorite. And we'll look at those in a second. Deleting our plus signs from the diff. So looking closely at these new mutations, note that we have an argument called favorite, and we're referring to favorite input in both of these cases. So it's sort of, you can think of it just sort of like a reusable object type that you can refer to by name. You're never querying this thing and getting a result back that looks like this. It's really for variables only. So next, we're going to go to the tweet component. I think this is the first time we've touched this component. So let's add all of these imports to tweet.tsx. Just add them right at the bottom. And there's going to be a mutation for sure, 2 of them. So we're going to say create favorite and delete favorite. In each case, we're passing in a favorite input variable, which is going to contain, of course, the tweet ID and the user ID. And what we're going to get back is just the ID of the like, right? The ID of the favorite entity we just created. Given that there's not a whole lot of interesting stuff that we can do with the information we get back, this will at least tell us something persisted. So we're going to paste this right above the component. And as usual, code gen on the server and on the client to get all of our types updated. So we're going to take on the back-end work first. To begin, we're going to need to import the favorite transform into our mutation resolvers. So we'll go to mutation.ts and add this import. In fact, if I use the organize imports, what happened there? Oh, I hadn't used it yet, so it removed it, just like I kind of told it to. I can do this one manually. We have an existing import up there, and it bugs me to have multiple things coming from one module if I can avoid it. So we're going to add 2 new async resolvers that have to do with creating and deleting a favorite. This is all going to go into mutation.ts. These are top level things that are happening. And looks like things are type checking as we'd hoped. So these are both very similar, so I'm just going to go over one and then point out the one difference between these two. So we're getting favorite as an argument. It is of type favorite input, which, as you would hope, is going to have a tweet ID and a user ID, just as we defined in our GraphQL schema. So there's our generated types, working well for us. We're going to create a favorite, which returns a promise. When it resolves, we get a DB favorite. This is that flat entity that gets up serialized as a JSON object in our database. Then we're going to return the transformed favorite object, right? This here, transform, that is my own word that I'm using to describe converting from a database representation to a GraphQL representation. And we're adding these embedded records here, getting a user by ID, transforming the tweet, right? We could probably do some more stuff here in terms of caching and things like that. However, remember, this kind of operation, we've got to think about this end to end, like when is this happening? This is proportional to a user clicking in the UI. So I don't expect this to happen like n+1 times. This is a top level thing. It is not something we're iterating over a list of things and we're fetching the tweet and fetching the user ID. So this is probably okay. We don't really need to think about optimizing this too much. If I were doing this for real, I would almost surely want to check to make sure that the user we get back is valid and that we're not creating tweets for users who do not exist in the system. Or likes for tweets that don't exist in the system. So there's our create favorite, and look at that. This is the only thing that's different. Delete favorite. That's it. They're both async. They both return the entity you're operating on, either the thing that was just created or the thing you just destroyed. Everything else is the same. All right, time to go to the front end. So we're going to go to tweet TSX. We'll start using the ID so we can remove this underscore in front of it and simplify things. And then we're going to create, again, two things that look very similar. I'm going to paste them in, and we will talk about them. So right before we return here, I'm going to paste the stuff from the website. So, and we got to change that ID thing up here because we're using this now. So what's going on? We are using newly created mutations that correspond to these new operations we created up here, right? So these are the things we're importing from our generated code. Down here, we're just using them in their React hooks. What are we getting back? We're getting back the function we use to actually perform the mutation. We're getting back an error, and I'm having to sort of alias that property because we have two of them now. And down here, I want to be able to disambiguate between error creating the favorite versus error deleting the favorite. But everything else you should have already seen. Now, this is where I'm doing something. I'm advising you don't think about things quite this way when you're doing your own code. We're being very heavy-handed in terms of refetching queries. This will get the UI working, but I don't think we need to fetch all of this information and like boil the ocean just because we'd like to tweet. I'm optimizing for different things here, like teaching you a set of concepts in a particular order, not making you jump around to a bunch of different files. So if you're feeling like this is a bit ridiculous and that you wouldn't do this in a non-training project, I hear you. But this will make it work. We refetch a lot of things. All right, now we're going to replace the contents of the handle favorite click function that's in the same component with this. And similar to when we created a tweet and we had that synchronous placeholder method that was just there, already wired up to the React stuff, now we're dealing with something that's async, and so we got to catch the error. This is always a good practice when you have a dangling promise This means that you at least get some feedback if things blow up, and it's just generally a good thing to do. Good for your future selves to leave, so you have clues to track down when things go wrong. So up here is this handle favorite click method, and we're going to replace this thing that used to console log based on is favorited. And now we still switch based on this, and it's create or delete based on that variable. I still see a red thing. Get current user from app. Save. Let's bump the TS server. Are you happy now? It is not. Why is this not happy? Did I rename that foolishly? I did. I replaced all current. Sorry, that's my bad. I did an aggressive Control F and replace. No harm done. I want to check one more place to make sure I didn't really screw things up. Timeline. Sorry, I'm just trying to think where else might I have used that. Nope, it's being used here. That didn't get changed. I think we're good. Okay, so so we should now check to see whether we can like and unlike tweets. So let's refresh, click some hearts. Hey, look, the counts are going up. You can unlike. Count goes down to 0, to 1, to 5, to 4. This is all using set state behind the scenes. Again, there's a lot of data fetching that's happening in the background, but on the one hand, it's a little overkill for such a simple interaction, and we probably could wrap this in a container component and validate something on a little smaller scope, like invalidate the data on a smaller scope. On the other hand, what we're doing here is going to be proportional to a user interaction that's not going to happen like 1,000 times a minute. So no one's going to be melting down a data center due to this. Great. Our favorites are interactive. The final thing we're going to do to our Twitter app is populate this part of the UI down here for trends. At this point, this is the only thing that's still coming from fixture data. And we're going to use this opportunity to talk about a new concept in GraphQL and how it relates to TypeScript, and that's the idea of union types. So we have this concept of a union in GraphQL. You're almost certainly you've used this before in the TypeScript world. And this is a case where you can have multiple things that are trending. You can have a hashtag that's trending, or you can have a topic, and that topic might refer to some entity for which we have a name and an image, and that'll sort of be shown in a little card. So this is going to be a case where you'll make a request that will give you a mixed bag of results. There's sort of some polymorphism happening here. And we're going to have to think about how can we create that? And then on the receiving end, how can we process that? Even how do we query for this kind of thing, where our mixed bag could involve different properties depending on which type of entity a member is. So as usual, we will begin by modifying our GraphQL schema. Let's grab this and paste it in. This should be self-explanatory. We can see tweet count is something that is common between hashtag trend and topic trend. Topic trend has the possibility of having a topic trend quote associated with it. And so this is kind of the nested record that's only there for the topic trend. And then, of course, what the user's asking for is just give me trends, a mix of both of these things. Give me a list of these trend things. So hopefully fairly straightforward. And into the schema they go. Put them right at the bottom. Great. We're also going to almost certainly, yes, have to add a top-level query, right? This is the entry point. This is how is somebody asking for a list of trends. So let's add that to our query type all the way up at the top. And finally, just to get the last little bit of GraphQL stuff out of the way before we run our code gen, this is what we're going to add to our get current user query. This is much more than the current user at this point, right? We're getting the suggested people to follow. We're getting, we're going to get trends now. So we can think of this almost like the initial load for global things in our particular version of Twitter that has no routing. So there's some new syntax here. ... on topic trend, ... on hashtag trend. This is basically telling GraphQL what to do in the case that a member matches one of these two types. And within these braces, we get the opportunity to describe the fields we're interested in on a per member basis. So for example, like we're getting tweet count on both, we're getting this deeper object only in the case of the topic trend. So we're going to grab this whole thing, we're going to drop it in. In app.tsx, in our get current, let me make sure I wrote that down. Yes, app.tsx. In the get current user summary, and we will just add it as a top level thing because it's a top level query. Oops, I did not copy that. Great. All right, time to code gen. Client, yarn code gen. And in server, yarn code gen. Awesome. That should be good. All right, let's handle the server part first. So we're going to need to create a little transform, and this is the most interesting one because we have to use a type guard. And I have, on the database representation of these topics, I've given us kind. So let me show you the database types for these things. Let me collapse this one. Kind, and it has a string literal type. Does anyone know what this is called? This is trivia. This is not about do you understand TypeScript. This is about do you remember the specific words we use to describe. Checking for this and narrowing types based on this. Nicholas got it. Discriminated union. Good job, Nicholas. That's the fancy type theory word to use here. So effectively what that means is, we'll see when we paste this in, we can check for that field, and that will let us, in one branch of our code, like if up here, T could be a trend of any kind. And what does that mean? It's either of these two things. Now, if kind is topic, well, we know we're a topic trend. Otherwise, it's everything that's not a topic trend, which is a hashtag trend. So you can use this kind, property and string literal types to have a discriminated union, effectively discriminating or, doing special things to cater to either of these two types. It's a kind of a common pattern to use. Of course, I like using the word kind because it's not type. The word type is way too frequently used in this code base as it is. All right, so we're going to add a new top-level query resolver in our query.ts because we've got that new trends that returns an array of trends, right? Like in our schema, we added this. So now we need to go to the query resolver and add the appropriate resolver for that. So here's the import for the transform, and here's the resolver. a really simple one that just passes things straight through from the database through this map function and out. I'll put that up at the top just to make it easy for folks to read. And bump ESLint, which is still unhappy with me. All right. Next. Well, I want to show you what happens before we go on to this next step, because we can see the problem that the next step solves. Trends. Let's ask for trends, and let's just get the hashtags that are trending. So the error message we get back says this abstract type trend must resolve to an object type at runtime for field query.trends. Either the trend type should provide a resolve type function, or each possible type should provide an isTypeOf function. This is telling us we need something that helps us sort this mixed bag into different piles so that those can trickle through their respective resolvers and then be put back together in this different mixed bag, right? So the way we're going to solve that is taking the first suggestion, which is resolve type. So we're going to create this special method in a new resolver for trend. It's _resolve type. And you can see what's happening here is we're basically using a type guard. We're saying, look, if this contains a property called hashtag that is a string, let's call this a hashtag trend. Otherwise, we call it, a topic trend. This will solve this problem. Trend.ts in our resolvers folder. This is because, although it's a mixed bag, GraphQL needs to know which members need to go down which paths in the tree of resolvers. Oh, I didn't wire it up to the main object of resolvers. That would help, right? All right, let's do that. So we're going to just do this. Yep, it effectively was just never being used, as if it didn't exist. All right, let's check it out now. Boom. There we go. Yeah, see, oh, isn't that interesting? I get like an empty object, and then an object with the field I asked for, and then an empty object. What do you think's happening here? It's the other flavor of object. So effectively, unless you say, give me a certain set of properties, and you cover all of the bases, you have the potential to get back empty objects. Something else you can add, it's a good thing as a debugging step. Type name. Actually, let me see if we can do this. Look at that. That's a nice way where you can sort of see, like, hey, what else is coming in here? And I think, can I do this? Nope. It's not even going to let me do that, even though in theory it's a common property that exists on all of the things, but that you'd have to be pretty sophisticated to know what that means, and it could be a totally different thing in both cases, right? So yeah, hopefully this is good if you're an example-based learner and you kind of can just look at this and see, hey, this is the observed behavior. It helps you form a mental model for how it works. Can I do both? Now I'm curious. Hey, yes, I can. So cool. I think this means our backend stuff works, right? The last thing we need to do is wire this up to the UI. So we're going to go back into our app.tsx. We're going to add one more destructured thing in our array, in the object that we're pulling properties off data, which is everything that's coming back in this GraphQL query. App.tsx. Here it is. Boom. We just added that little piece there. And filter through the trends. because, interesting. I'm going to try without filtering just for fun. I think this may have been nullable at one time, but it's not now. We'll have to see. All right, right bar. We're going to pass the real trends into this right bar component instead of the fixture data. There it is. Yep, I think it might have been nullable in an earlier version of my project. It wouldn't have hurt if you put the filter in. It's just kind of pointless. And let's look at the UI. Hey, we got a lot of trends here. And these are the little quote things that are attached to the topics, right? So this is a topic trend. Here's a hashtag. Here's a topic with the little attached thing. So we get, a list of these things. A mixed bag, a union type working through GraphQL into TypeScript. Actually, from TypeScript into GraphQL and back into TypeScript. And that is it. We're done with the app. All right, Nicholas has a good question. He asked a couple minutes ago, could we define a type for verifying if something has a hashtag key instead of using object as any? And I'm going to guess he is referring to, in the trend resolver, this thing here. So yeah, we have a little bit of a challenge here. First off, actually I think we do. We could do it like this. This is a better way to do it. It's good you asked. Oh, actually, it's tricky. I'll tell you what I was just thinking. I was about to reach for kind. I was thinking, hey, we already have this kind string. Like, it's something that's stored in our database, right? If we look at the trends, should maybe at the bottom. Yeah, here, it's actually a field. You think of this, there's a column in our database and it's serialized in there. We should be able to rely on it being in there. However, important to remember, this is the GraphQL representation of that entity. So what we could do, instead of doing this, we could, in this query, as we're assembling this, we could use that cache strategy where we would, while we have access to the DB representation, which is, it's this object here, we could maybe build up a map that shows, here's the trend ID, and it is a hashtag trend or something like that. And then as we're being asked to sort out deeper down in this function, like, all right, here's a GraphQL object that has no kind property, right? What is its type? We could then reach into this context object and sort out, what's going on. Does that make sense? Now, this is also totally fine. Like, I know this field will be there. So I would say that this is okay. It's effectively a user-defined type guard, but in the GraphQL world instead of in the TypeScript world. Yep, many ways to do it. You could either do some bookkeeping or some introspection. What should I remember as a summary after the course about the cache in terms of which queries we cache and why? And he also mentions like n+1 queries. What should I remember about that? So my answer there is, I'm going to paraphrase that question a little bit. I think what he's asking for is a sanity check. Like, how do you know you're caching in the right places and not worrying too much about caching in places where it matters less? I would say just study your schema and think about how it's going to impact your resolvers. Things are either going to be called one time or n times, usually. It's just, is it a current user thing or is it an n times thing? And it does get a little bit more complicated, and this is a challenge with GraphQL. You can't always be sure what's going to be called in what order, and this is the most hand-wavy answer ever. The more complicated your schema gets, the less confident you can feel about like users will only be accessed on a per one-off basis. Here's an example. You could look at this, and we've said this, right? Based on the kind of queries I'm making, it's totally fine when we go to a user and we say, give me your stats, and we go and get the whole list of likes that they've made and like get all of those into an array. Well, that may have been fine at one point, but I could also get all the tweets and the authors of those tweets, which are of type user, and then start reaching into those users and getting some of this really expensive stuff. So try to avoid the n+1 queries, but it's the kind of thing where you have to stay well organized. It's one of the main challenges of working with GraphQL. You have a system here that has very little information about how is this information being used and in what circumstance. You can ask it for whatever you want, and that moves the problem. The problem is now, how do you fulfill a wide open set of possible requests people could make in a way where you can guarantee things will be performant and that your systems won't be degraded? An approach that some companies have taken is limiting queries, where maybe you can only ask for certain things on users if it's a one-off request for one user. And they'll give you a server error if you try to ask for it in a context where it's going to degrade things too much. So, you can't, making something that's fast and easy and consistent and very, 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 very performant all the time, like that sounds like a zero trade-off situation, and those generally do not exist. I'm not sure how much useful information there is in that answer, but it's kind of a gray area. This is about like system architecture more than how do you put these pieces together to form a full stack TypeScript app. Thanks very much for building this Twitter app, a full stack TypeScript app where the client and server are connected with GraphQL. I hope you can see that some of the benefits you enjoy with writing TypeScript code either on your server or your client, now we get some of those advantages across the stack, where as we refactor things, as we change things, type information is telling us where we need to finish up and complete our refactor all over the place. So it's a great way to set things up, and hopefully it provided a great experience for you and you learn how to use GraphQL and TypeScript together. Thanks a lot.